In this chapter, we transition from analysis activities in Core Process 3 to design activities in Core Process 4. This video introduces the fundamental concepts associated with systems design. As discussed earlier, the primary purpose of Core Process 3 was to understand the business needs and the details of all the user's requirements. As we understand what the requirements are, then we start to design a solution. Hence, the starting point for systems design is the understanding that comes with analysis. However, the final objective of a development project is to implement a new system. Thus, design must lead directly into implementation. As we do systems design, we always need to keep in mind that we are modeling, documenting, and designing for the purpose of being able to implement. The objective of systems design, both at a high level and at a detail level, are to define, organize, and structure the components of the final solution. These components may be as large as an entire subsystem or as small as a single method or routine. We design as needed to be able to implement these components. In this figure, we summarize these points. The objective of analysis is to understand and specify what is needed. The output are analysis models. The objective of design is to define and describe at a detail level how the system will work. This is also documented through models. The objective of implementation is to construct the new system. The output is a working and deployed software system. As indicated, design is a model building activity. Of course, models come in various forms and types. Many of the models you will learn are UML models, but other models such as narrative description or ad hoc diagrams can also be used. The formality of the project itself will influence how we model and the form of the models will take. Sometimes we just scratch out a design on a piece of paper. Sometimes we will formally draw computer diagrams to produce a model. We continue to be guided by agile principles and practices. We only build the models that move the project towards implementation. Finally, we need to mention that there is a danger in what is sometimes referred to as cowboy coding. Cowboy coding is where developers jump right into coding without doing any design or only minimal design. Usually that results in poorly designed and constructed solutions, as well as often requiring rework when components don't work or don't integrate with other components. Every system has a design, if it is done consciously or whether it is just some random structure. Let's take a minute and review some of the UML models we have used during analysis and what the resulting design models will be. One of the big benefits of object-oriented design is that many of the design models are simply extensions of the analysis models. In other words, to do design, we take one or more analysis models and manipulate them or enhance them to do the design. Let's zoom in a bit to discuss these models. In this figure, we see three design models. At the top is a component diagram. A component is a piece of the system that can be identified as a separate entity. Often we consider a subsystem as a component. Another component might be the web server that we use to deploy the system. A component diagram is helpful to identify these software components to see how the total system fits together. The next diagram, the deployment diagram, documents where these components are placed on which computers and which servers. Thus, a component diagram and a deployment diagram work together to identify the software components and document the hardware where they are deployed. The next diagram, the design class diagram, documents the attributes and methods of each design class. As noted in the figure, it is a direct extension of the domain model class diagram. You will learn the steps necessary to convert a domain model class diagram into a design class diagram. The next design model is called an interaction diagram. There are two types of interaction diagrams that you'll learn about: communication diagrams and sequence diagrams. Interaction diagrams describe how the various classes in a system work together to carry out a use case. Basically, an interaction diagram describes the execution of a use case by the system. As shown from this figure, an interaction diagram is developed based on the information from the use case diagram, from an activity diagram, and from a system sequence diagram. Finally, we have a design state machine diagram and a package diagram. A design state machine diagram is frequently the same diagram as was developed during analysis. A state machine diagram describes the internal methods or transitions that must be included in order for a class to be well behaved. As such, it is used in conjunction with the design classes. Finally, a package diagram is used to aggregate classes together into software packages, either for descriptive purposes or even for deployment as packages. This figure highlights the design activities associated with Core Process 4, Design System Components. The activities themselves indicate what elements of the new system must be designed. Design steps and processes are different for each type of element. Of course, these activities are often carried out concurrently because the design of one element impacts the design of all the other elements. The first activity listed is to describe the environment. We use the term describe rather than design because most organizations already have implemented some information systems, and the new system must fit in and conform to the existing environment. Of course, there may also be some designing of new elements in the environment, but it must also integrate with the existing environment. Next is design the application components. This activity is considered high-level design. Its purpose is to define, describe, and design the structure of the new system. In other words, to identify and define the major components and how they all work together. Sometimes it's referred to as architectural design. Next is designing the user interface. This activity is a mixture of analysis and design. It requires heavy involvement by the user to indicate what the screens, forms, and reports look like and how they work together to allow the users to do their jobs. Next is designing the database. This, of course, is a core piece of the final system. Finally, design the classes and their methods. This is the other core piece of the final system. One way to help us understand these activities is to consider each in terms of a basic question that needs to be answered. Describe the environment. The question might be, how will the system interact with other systems and with the existing technology configuration? Number 2, design the application components. This question might be, what are the key parts of the information system and how do they integrate and interact together in the final deployed system? Number 3, design the user interface. The question might be, how will the users interact with and use the new system? Number 4, design the database. The question might be, how will data be captured, structured, and stored in the new system? And finally, design the software. The question might be, what is the internal structure for each application component, including the classes and the methods, to ensure a solid, reliable solution?